Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we will be solving or starting to solve the UPSC CS Main exam 2020, which this is the optional subject that has the that is based on the chemistry subject. Okay, so we'll be calling this as CS Main UPSC exam. Okay, CS Main UPSC chemistry. Okay, this exam is basically for the people who aspire to be either IS for the IS post, obviously. Okay, so this paper is the paper number one. We will be solving just the paper number one. Okay, paper number two will be solved later on. Okay. So, firstly, we must understand the pattern for this question. That is, paper is not MCQ like any other competitive exam, but it is more of a subjective type exam. Okay, there's a pointer. Yeah. So this is a subjective type exam. Okay. So for this we have to write the answers in a precise way, in a compact way. Each question would be carrying from 5 marks to 15 marks. Okay, so these are the things that you need to know. Here as there is no multiple choice, so therefore there won't be any negative mark for the wrong answers. You will just be given zero if you're not writing anything, or you're attempting it wrong. Okay, so the main thing that needs to be taken away from this paper is that we have to write, as this paper is a subjective paper, we have to write each and every questions in a proper manner. The answer for each and every question should be written in a proper manner and in a most brief and the compact way that is more possible for you guys. Okay. Obviously, we have to take the marks also in consideration, because for a five marks answer, you won't be writing so much up till 15 marks. That is the most basic problem that many students do, and that is why they don't get good marks. Okay. So these were the things that you guys needed to know. Now let us just look into the topic. I guess we have 40 questions in this paper. Probably 40 questions. We'll be seeing that as we solve one by one. Okay. So this paper, as I have in my PDF, it is there in given in Hindi also, and in English also. Okay, so I'll be considering obviously the English one, and then solving the question accordingly. You may just go through, just download this question paper from any website available, obviously from searching from Google, and you may just follow from that PDF also. Okay, so let us now dig into the matter. We have question number 1A. Here question is the total number of questions is 8. Okay, and each of the question is divided into 4 or 5 sub questions. So we will be looking into them one by one. Okay, so the first question, that is question number 1A, it said that the dissociation energy on going from N2 to N2 plus. Okay, the pointer. Yeah, so N2 to N2 plus, whereas increases on going from O2 to O2 plus. Okay, so we are talking about the dissociation energy, or we may say bond energy, or we may say bond order. Okay, all these terms are completely related. The type of relation I'll be just explaining to you. Firstly, let me draw the diagram, that is the energy MO, the molecular orbital diagram for the N2 and the O2 systems. Okay, both of them would be having the same, so I'll be drawing just one diagram and I'll be explaining to you in that way. Okay. Oops. So we have an energy axis over here. We have this, we have this overlap. This drawing is obviously not up to the scale. I'm just making it to make you guys understand. So you may just uh, look into this. Okay. Okay, so this is the 1s level, this is the 2s level, and this is the px, py, pz, that is the 2p level. Okay, 2p level, px, py, pz for both the species, px, py, pz. That this is the 2s orbital and this is the 1s orbital. Here, this one is the atomic orbital for one nitrogen. Let us first consider the case for N2. So we will be drawing that. So atomic orbital of one nitrogen, and here the atomic orbital of another nitrogen. Okay. So we have the total number. The electronic configuration of nitrogen is 1s2, 2s2, 2p3. Okay, so here we have 2 for one nitrogen, here we have 2 for one nitrogen, this would be giving up the total configuration. Okay, similarly for 2s we have 2 electrons, 2 electrons, 2 electrons. Now P3 is there, so each of the suborbital would be having one electron. Px would be having one, Py would be having one, Pz would be having one, and this would be like continued in the other atomic orbital of n also. This structure in between is the molecular orbital of n2. Okay, so what would happen is two electrons would pair up to give a pair of electrons over here, then pair up over here, and then pair up over here. Okay, now so this is the case. Now the middle part in each of the set is known as the barycenter. Okay, barycenter, and therefore or the non-bonding set of electrons is the below the this barycenter we have the bonding amos, and the above the barycenter we have the non-bonding amos. Okay, I'm sorry, anti-bonding amos. The anti-bonding amos, ABMO. Similarly, for this case also we have BMO over here, we have NBMO over here, ABMO over here. Okay. For this case also the lower part is the BMO, that is a bonding molecular orbital, and the above part these three sets of regions where the molecules can where the electrons can reside, they are known as ABMO, that is the anti-bonding molecular orbital. Now for this case we can calculate the bond order. Okay, now what is bond order? The formula for bond order is given as number of bonding electrons minus number of anti-bonding electrons divided by 2. What is bond order? Basically the number of bond that will be present in between these two ends. Obviously we are taking N2 molecule, two of the two ends are being atoms of N are being involved to reacting to form the N2 molecule. So the bond order between two ends would be, so then these two, the difference between this BMO and this BMO is 0, because two electrons are there also, two electrons are there also. Similar for this case also. So we will be considering the px orbitals, the 2p orbital one. So here we have 6 electrons in the BMO one and 0 electrons in the anti-bonding molecular orbital. Okay. So 6 minus 0 divided by 2, which is equal to 3. So the bond order for N2 molecule is 3, and as we know the structure of N is N111N, which is the bond number is 3. Now the question says that when we move from N2 to N2 plus, what happens is one electron should be removed from here. Okay, let us just remove one electron from here, and we have just one electron over here. So N2 plus, so this would be the species formed. In the BMO there would be 5 number of electrons. So here we would be having, instead of 6 we will be having 5 minus 0, which gives the bond order to be 2.5. Now as the bond order is 2.5, the number of bond that has been decreased as from, obviously this is a hypothetical scenario, so number of bond between two ends would be 2.5. Okay, now the breaking of bonds, number of bonds, the breaking of 3 bonds is comparatively more difficult than breaking of 2.5 bonds. Okay, so therefore the dissociation energy decreases when moving from N2 to N2 plus. Okay, dissociation energy decreases. Okay, now what let us now consider the case for oxygen atom. Okay, this is a 10 marks question, so you have to write quite a long thing. So the in the oxygen, I'll be just showing you the p orbital part. So you can just copy the 1s and 2s orbital part in the oxygen, and both the and the nitrogen part are the same. So you may copy it as they were like given. Okay. So we have, okay. So we have here px, py, pz. We have the px, py, pz. Okay. Now the electronic configuration of oxygen is 1s2, 2s2, oxygen, 2p, 4. Okay. Now after nitrogen comes oxygen. So we have 4 electrons over here, and we have 4 electrons over here. Okay. So what would happen is pairing up would take place. We have this set, and we have two unpaired electrons in the above level. So total of 8 electrons are there in the molecular orbital system. Okay, and this, because of the presence of unpaired electrons, we know that oxygen is paramagnetic, O2 molecule is paramagnetic, and obviously nitrogen was diamagnetic because it had no unpaired electrons, is diamagnetic. Anyways, so if we just for this system, we calculate the bond order. So we have bond order would be equal to, we have 6 electrons in the BMO and 2 electrons in the ABMO. So 6 minus 2 divided by 2, which is equal to 4. I'm sorry, not 4, 2. So, and that is the knowledge that we know, because of the we know that O2 molecule has a double bond in between, that is O double bond O. Now, what would happen is, if we move from O2 to O2 plus, that we oxidize O2 molecule and remove one electron from the system. So what would happen is, this part would remain empty. So here we have, instead of in the ABMO, there is only one electron. So instead of 2, here we will be writing 1. So 6 minus 1, which is 5. 5 divided by 2, which is equal to 2.5. So here in this case, bond order is increased. So instead of O2 having 2 bonds, O2 plus would be having 2.5 bonds, and therefore the bond breaking for O2 plus would require more energy. That is, breaking of 2.5 bonds is more requires more energy than breaking of 2 bonds. Okay, and therefore the dissociation energy of O2 plus is more than that of O2 molecule. Okay. So yeah, so this was the correct explanation and the correct answer for this 10 marks question. Moving on to the next question that we have, that is question 1b. Okay. So question number 1b is kind of an easy sum, so you may just do it quite easily. So it says an orthorhombic unit cell has the following parameters, that is A equal to 0.5 angstrom, B equal to 1 angstrom, and C equal to 1.5 angstrom. So what will be the smallest spacing between two successive 1, 2, 3 planes? Okay. So let us just write down the formula for this. For an orthorhombic cell, for an orthorhombic cell, we know 1 by d square HKL is equal to h by a square plus k by b square plus L by c square. Okay, this is the appropriate formula. Obviously, these are all applicable for any kind of cell, but for in case of cubic, we know that A, B, C are all the same, because obviously cubic, it is the system is cubic. All of the sides are same. Okay, and for the orthorhombic cell, that is not the case. Anyways, so this is the like basic formula that we'll be using for solving this question, and obviously the values that are given is given. A would be equal to, A is equal to 0.5 angstrom. Now let us consider this to be x, just for the sake of calculation. Why I am doing this, you will be figuring out just a bit later. So B is given to be 1 angstrom. We just take it as 2x. Obviously, 0.5 is x, so 1 would be equal to 2x. And C is equal to 1.5 angstrom, which is equal to 3x. Now you know the trend. Okay. And the value of H, K, and L are given to be, the plane that is given is 1, 2, 3 plane. So the value of H is 1, the value of K is 2, and the value of L is 3. Okay. Putting the values in the above equation. Putting the values We have 1 by d square h k l would be equal to h by the value of h is 1 divided by x square plus 2 by 2x square plus 3 by 3x square. We just put the values of all the parameters that we all the values that we had in our data. Okay, we have hkl, these values, these values, these ones, and we have the abc values which we have considered to be x, 2x and 3x. So here these would cancel out, 3 would cancel out. Moving on to the next page, not the page obviously. Okay, so we would be getting here this would be equal to 3 by x square. Okay, so obviously one so d h square l would be equal to d square hkl would be equal to 3 x square by 3, and d hkl would be equal to x by root 3. Okay, x by root 3, this would be in angstrom obviously because we are taking all values in angstrom. Now what the main case scenario is, we cannot keep the values like this because we have taken x to be equal to 0.5. Okay, so we will be just putting the value of 0.5 angstrom divided by root 3. So let me just calculate the value for you. um, so we have 0.5 divided by root 3, this is equal to 0.2887 angstrom. This would be the correct answer. Okay, so let us continue with this. So this was question number 1b. Okay, so question number 1c is kind of a big question, so we will be just keeping that question for the next video. Okay, this video is already more than 15 minutes, so let us end this video. um, Thank you guys for this video. I'll see you guys in the next one, and we will be solving these questions furthermore. Okay, so thank you.